So we are starting a new chapter on cloud. This chapter is very much interesting in a sense of that we are experiencing most of the time different types of cloud and precipitation. We also some of us are very much interested about to know of their formation process. Some of also very much interested about the characteristics of different sets of rainfall pattern, and it is also very interesting in a sense of that we can also experience this from our naked eye. We can see it very clearly. So in this chapter we are mainly going to discuss about the cloud and then the product of the cloud, that means different precipitation. So first of all we are going to discuss about how the cloud can be formed, and in relation to that in the second lecture maybe we will going to discuss about the process of radiation balance. That means the one of the important thing for cloud formation is to know about the total radiation that is coming from the sun to the earth surface, and again how can it go back. So we'll know the process in relation to energy balance, and then we'll try to understand the other types of component that is formed in the environment, such as dew, frost, haze, and fog, how it has been formed, because they are different forms rather than the cloud, and they are formed due to different conditions. We're going to discuss about that, and then we're going to discuss about different types of cloud. What are the different types of cloud we can find in the atmosphere, different atmospheric layers also. And in the second part of this chapter we're going to discuss about different types of precipitation, such as rainfall, hail, snow, different types of precipitation. We're going to discuss about that. And the very last we're going to discuss briefly about the measurement process of the precipitation. uh, Previously we use only the manual process. Nowadays we are also involving some of the technological aspects in measurement. So we're going to discuss about those types of technologies for precipitation measurement. So this is a very general idea how the precipitation or cloud can be formed and come back. Basically the source of the cloud, that means the water vapor, is coming from the water surface, mostly from the oceanic surface. And this oceanic surface is much more important because these are the areas always the sun rays fall on that, and then the evaporation takes place. Some of the water vapor also coming from the trees, vegetation cover, as a means of evapotranspiration. Transpiration and evapotranspiration, those plants give us some water to the environment, and both together basically their contribution is not too much, but most of the water is coming from top of the surface of the water, and then sufficiently heated up go to the top of the surface or the upper surface, and eventually they turn to different forms. One form is when the water vapor go to the upper surface, they become cool, because we know from the previous chapter when the water vapor or anything goes to the upper surface, then due to the lower temperature, that can be turned to the different other forms. So water vapor come to in a position to form water droplets, and then a liquid form to again the hard form, that means solid form, crystal or ice. So they can also be changed depending on the temperature, depending on the other components of the environment, such as relative humidity and others. So they go to the different stages. So you can see there are some clouds in here and there are some clouds in the here. uh, so these clouds downward and upward, their characteristics also be different because of the altitude, because of the materials they involved. You see the lower clouds are looking little bit grayish in color. On the other hand, in the higher altitude, the clouds is looking white in color. And also that should be little bit older in form, because that is in higher altitude and temperature is much lower in here. On the other hand, the lower cloud, they don't have such high temperature, but still they have different other combinations so that they can also form liquid droplets. I'm gonna explain that. So cloud, the very simple rule is water liquid form, they turn to the water vapor form with the heat energy, and this is the process we called evaporation. And evaporation will take place until the vapor pressure in the atmosphere is less than the saturation vapor pressure. When the saturation vapor will present in the atmosphere, then the water will come down as a form of the liquids. So evaporation will be no longer possible in that time. That means you have 100% capacity to fill up of your environment. So further evaporation is not possible. Then from the evaporation, vapor form, they can also turn to condensation, condensed form. That means again they come to liquid form uh, when when there are certain condition takes place. As I said, if it is go to the upper surface, then the temperature will be very low, and then near to the relative humidity, when it approaches 100%, they wanted to again come back. That means they wanted to condense in a form, and condensation form means they become heavier, and they will come back to the earth surface. But condensation will take place on two conditions. One is if it is in a higher places, they prevailing the same moisture, they have vapor pressure same. That means the vapor pressure and moisture are not changing, but temperature has been changing, and due to lower temperature, the condensation can take place. That means relative humidity approaches to 100%. On the other hand, in the lower altitude, we don't have such lower saturation point or lower temperature. So in the existing temperature also, we can also have condensation when the condition is we should add more moisture in there, and more moisture means more vapor pressure, and then again condensation can be possible. So two different ways. One is you can add more vapor, that means more vapor pressure, and also it is possible you don't change the pressure is same. That means moisture is same in case of higher altitudes, but the temperature is different. In that case also it is possible that relative humidity approaches to 100%, and relative humidity 100% means the condensation takes place. Can you understand it, or you can ask me again? Hello?
Sir, I didn't understand, sir.
Or you can ask me, I can explain again.
Sir, can you explain again, please?
Okay. uh, when the evaporation takes place, that means the water vapor go to the from the surface to the atmosphere. That is fine, but why it is formed cloud, and why it wanted to come back again to a form of the liquid or water droplets? Because when evaporation takes place, that is water vapor, that is not liquid anymore, and due to the lightness of the water vapor, they can move upward, and until it get reaches to a saturation point. What do you mean by saturation point? Saturation point means when the water vapor may not be possible to remain in the air, they again come back to water form, water droplets form, and that is called condensation. Condensation can take place depending on certain conditions. So there is two different ways that condensation takes place. Always the humidity should be approaches to the 100%. How it can be possible? On the basis of two different conditions. If the water vapor is in the upper atmosphere, that means they're going to be very cold, and due to lower temperature, it might be possible that existing moisture and moisture vapor pressure, they are existing in a same condition, they are not changing. So with the lower temperature, it might be possible that relative humidity approaches to 100%. On the another condition, when you add more moisture, more pressure in the lower atmosphere, that means lower atmospheric layer, that time the temperature is not very cold, and due to the existing temperature, it is also possible that it can turn to full saturation point if you add more moisture in there. So one is you can add more moisture, and another is you can add more lower temperature. So two different things, and those two can give you the opportunity to become relative humidity approaches to the 100%. Now maybe you can ask me, what do you mean by relative humidity? Relative humidity is a term which can we use that how much humidity or the water vapor is present in the atmosphere right now, on the basis of how much humidity that maximum humidity can possess by the atmosphere. For example, in a given situation, maybe 100% of humidity can be possible in a given situation, in a given places. And now you have 70% of humidity in there. That means uh, you can allow more humidity in those area, and if it is 100%, then it might not be possible that it can hold it, then it will come back again as a form of water or water droplets. So that is relative humidity. This is a ratio between the existing humidity and what amount of the humidity you may possibly have in your certain location. So this is a ratio. So that humidity going to approaches 100% when two condition is there. One is your moisture is same, vapor pressure same, but temperature is lower. Another is your temperature is constant, but you can add more moisture in there. More moisture means more vapor pressure. So the two different conditions can make the condensation process, and condensation is necessary to come back this water vapor to liquid form or solid form. uh, in case of lower temperature, that means when you add more moisture, how it can possible that they can go for a condensation process. There are certain other things that can enhance this process. That certain thing is named is condensation nuclei. Condensation nuclei is a mechanical surface which can give you a place where the water drop can be attracted. They can come together and form a great value. That is a condensation nuclei, and this mechanical surface is coming from different sources: smoke, soot, pollen, dust, other particulate matters, anything. But this condensation nuclei is so tiny and so light that it can prevail in the atmosphere for long times, long days also. How light they are? uh, it is estimated that a mass, they have a mass less than 1 trillionth of a gram. 1 trillionth of a gram. That means so tiny, so light. And it is also abundant in most of the cases in city areas. And sometimes it is also possible to uh, find out where the pollution is maximum. And sometimes it is also possible that in an area where there is much of the pollen grains or dust can be possessed. It is estimated that in a cubic centimeter of an area, 1 million particles can remain. So you can understand a cubic centimeter is like this much, very low, very small. And this amount of the area, 1 million particles can prevail. That means you cannot see in your naked eye. And then this type of nuclei that can prevail in the atmosphere, mostly in the lower atmosphere, and those those particles give the opportunity to the as a surface area, so that the water vapor come together and they become form a water droplets. And this nuclei is of two types. One is hygroscopic, another is hydrophobic. Hygroscopic means there are certain nuclei, condensation nuclei, they have characterized that they attract the water vapor or water particles in their body, in their surface, and make them happen that relative humidity is considerably lower than 100%. So so that means if you don't have 100% humidity also, but also this hygroscopic nature of those particles, they can turn to water vapor to the liquid form. A good example is our table salt, which you can use in our daily processes. So you will find that in a humid weather, in rainy season, the pot of the salt, it is very hard to pour it down. Why? Because of the hygroscopic in nature, the salt attract the water vapor or humidity in their body, so they become very sticky, and you cannot pour it down to the outside. And this hygroscopic nature make them happen to come closer. That means water vapor come closer, and you can also find some liquid in your pot, in your salt pot. So this is why these particles, these hygroscopic nature, they take they catches the surrounding water from to onto their surface. Such like salt, there are some other types of hygroscopic nature of the nuclei is sulfuric and nitric acid particles. They are also in hygroscopic in nature. On the other hand, some are very hydrophobic in nature, such like oils, paraffins, gasoline. They are such like particles. They don't like water, and they actually resist the condensation. So so even the relative humidity is approaching to the 100%, nearly or above the 100%. But still, these hydrophobic nature of those particles, they are try to resist the condensation. So in the atmosphere, we can find both of them. We can find both of them, but in both of the cases, so we can understand, due to hygroscopic in nature, below the 100% of the relative humidity, it is possible to get the rainfall. But due to hydrophobic nature, even it is greater than the 100%, sometimes it also resists the water vapor to turn to liquid form. So whatever the cases, most of the cases, when it is formed the cloud, fog or haze, that means the relative humidity is around 100% or below the 100%. That means it is near to there. Okay. And you can see this is hygroscopic in nature, so that the water, these particles are seeking water, but this in here, even the water vapor come to them, but they don't allow to their body to come closer, and then again that water vapor moves otherwise. So that's why in this way they resist the condensation. Now come to the point how this cloud can be formed. Basically, the cloud has been formed with the involvement of the high energy that is coming from the sun. This is the basic source. We can say these sun rays, that means the energy fall on the ground, fall on the top of the surface of the water, and then they become very turn to water vapor, and then they move to the top of the surface. How they move, I will explain now. And then again they will come back when the water molecules become larger, uh, approaching the 100% humidity, or maybe there are some condensation nuclei in there, and they become heavier, and then they come back to the earth surface by the act of gravity. So due to gravity, it come back again to the earth's surface as a precipitation. And precipitation can be different types. It can be rain, it can be snow, or it can be a ice form like hail and sleet. So these are the ways how the water vapor move to the top of the surface. There are four basic different ways the water vapor go to the top of the surface. First of all, if our area is very limited and evenly sun rays fall on the ground, then water vapor directly move to the upward, and the area covered by this way is not too much. It is only maybe some sorts of 5 kilometer area. So this 5 kilometer area, if the water vapor prevails, and then within that area, if sunlight fall very evenly, then it directly move to the top of this atmosphere. And again, other formation that will come back again. This is one way to see. This is called surface heating and convection. Another way, if our temperature is temperature, if our air movement is taking place in a certain area, then large amount of the water vapor, they can move forward, and due to its movement to any of the way, for example, in our cases from south to north, so all the way along it moves and finally found a barrier. When it found a barrier, so crawling up the altitudes, and finally it go to the surface of the atmosphere, top of the surface of the atmosphere, because it moves and go to the top. It is also one kind of lifting. So this lifting taking place due to this topography, due to this hill or mountain. Particularly in case of Bangladesh, if it moves to all the way to the north, and it's finally obstacled by the great mountain Himalaya, then it will come back again in a form that it moves to directly to the top of the atmosphere. Sorry. Or maybe it is possible due to very cold temperature on the top of the Himalaya, because it is a great hill, great mountain. So due to its lower temperature, it can also possible that they can condense there as a ice particles, or they can also come back to the lower area if the temperature is little bit low, and then they form precipitation, and rainfall will come back from that particular area. So both of the cases, they move to the top of the surface, top of the atmosphere, due to topographical condition. Another type of upliftment takes place due to convergence of surface air. Convergence means the two type of air is coming from two directions and come together, so that the middle of the area, the heated up portion, they move to the top of the surface, and that creates a low pressure system. It is not meant to be that this lower pressure is looking like the cyclones, because cyclones has much of the different other conditions also. But in here, what happened when the convection or when the convergence takes place, that means the temperature, high temperature, and this is air surface, they come in an opposite direction and they mixed air, and finally they wanted to move upward because of the lightness, and this lightness created the uh, air particles to move upward. And when these air particles move upward, that means this place will be empty, and this empty place created the lower pressure system, and finally these clouds go to the top of the surface. And fourthly, finally, another type of upliftment takes place when two cold air come together, and from the opposite direction, when it come together, in the middle of that, if warm air remain, then warm air wanted to go to the escape, on warm air wanted to escape, and they don't mix with the cold air, they wanted to escape means they will be on the top of the cold air because of their lightness, because the weight is lower. They wanted to be on the top of the cold air, and wanted to go upward. So here the cold air, you see this much, Here the cold air is like this. So in both the cases, the water vapor, that means warm air, they wanted to escape from their both of the pressure. And some of them go directly to the top of the atmosphere, and some of them very gently they moves on the surface of the cold air things. We say this is a front. When two different types of air masses come together, we say this is front. So lifting also takes place uh, during the weather fronts. So this is the way how the cloud has been formed. So in your exam, if it will come, then you have to explain like this, some of how the water vapor form from liquid to condensed form, and then vapor to liquid form, and liquid to other forms. So you have to explain that, and you have also you need to explain how it go to top of the surface, how it has been uplifted or developed. Is there any question until now? Do you have any question until now?
Sir, why the distance are mentioned under the sir pictures like 500 kilometer, 1500 kilometer?
Okay. Thank you. Very good question. Uh, think it, if it is possible that surface heating and convection, it might not be possible for a long distance. It should be in a very smaller area because of the evenness and because of not the air movement too much. So it is only possible for 5 kilometer area. But if you see this one, so air masses is a chunk of the air which carries a great distance. So cold air mass and cold air mass when come together, so each of the air mass is huge, and so it is written 1500 kilometer maximum. So it could be several hundred kilometers also, and maximum when they come from two different direction as a air mass, they actually cover a wide range of area. So that's why distance are taking place. So when we, for example, when we say the rainfall is happening from Chittagong to all over the Dhaka, that means Chittagong, Kumilla, and all the way. So that doesn't mean that it is started with such first one. It is not heating and convection. It is actually convergence of air, or it might be actually lifting along the weather fronts. That means the coverage is huge. On the other hand, if the convergence of the air mass takes place, that means two different directions the air is coming, that can typically cover an area of 3 to 500 kilometers. That means not all over the country of Bangladesh, but a particular region of Bangladesh. But if you say 1500 kilometers due to this cold air front and warm air front, maybe this will cover full of the and most of the part of Bangladesh. Sometimes we can also find this type of weather forecasting, that all over the country there we can see the rainfall. So this is due to because of this type of development of the cloud. But if you have only convection, so it might not be possible for the whole area. It might be a very local area. So in local area, they can, for example, we can expecting some rainfall in the Chittagong, but there is no rainfall in Kumilla or maybe Cox's Bazar. So it is a local convection. So that's why it is written the kilometer. That means how long it can, what would be the source of this type of cloud formation. Is it okay, Siam?
Yes, sir. Okay, sir.
Now the cloud formation has completed, but there are some other formation that also takes place in our environment, in different environment, not only our environment, different environment. One such example is dew and frost. We can experience dew in our life because in different country, in different tropical regions, dew can be formed, but frost may be not seen by not seen in our country because of the that needs also little bit different temperature, colder temperature. So how deep the dew has been formed? So dew can be formed, I can explain in it that way, that when in a night time the temperature is very cool in nature, and night is very stable, calm and quiet. That means there is no cloud in the sky. So the temperature can easily go away. That means all the daytime when the surface temperature has been heated up and different object that has been heated up, now they can easily release the heat from the ground. This is first. Then in the night time, what happened? The air temperature and the temperature on the ground object uh, uh, poses different temperature. So the object on the ground, such like grasses, twigs, vegetation, this type of ground, this type of ground object, they become much colder than the temperature in the air. So air temperature is more than these objects which remain on the ground. So there is a difference between the temperature. Okay, so this temperature, when this temperature prevail on the object, these objects they wanted to take some, sorry, okay, I'll explain it. Some of the temperature that also mix up, that also take some of these lower temperature objects such as grass, twigs and branches, they wanted to take the water vapor on their body. And those water vapor when fall on the surface of this object, then these grasses or these objects, they show these water droplets which we call dew. Shubro Hawk said, sir, in lifting along topography, we saw that because of mountain, the clouds are going to upwards. My question is, if there are no obstacles like mountains, then what kind of cloud formation it will be? Okay, fine. Okay, I'll just going there. Shubro, can you see this one? So if there is no topography in here, what will happen? They will move. Okay, they will move because their distance is great. And finally, they will come back either in convergence of air, or they will be obstacled by other type of two different cold air. As you have this one, we can expect this cloud formation, this is warm in nature. So when they will move until they will find another cold air, okay, cold masses from opposite direction, they will move. And finally, when they come together, they will make a lifting of the weather, another type of cloud, lifting along weather fronts. Or it might also be possible that two different directions, this one going in one direction, another direction will come together to form this type of convergence of the air. So if you have no mountain, maybe you cannot also, some of the cloud, they cannot go very further. Some of the air vapor, air pressure, they cannot go further because of this convergence. So for example, some of the air is starting to produce on the Bay of Bengal, they wanted to go to Himalayan range, but maybe when they move, maybe in Panchagore or Shiliguri or such like different areas before the high mountains, from opposite direction, another air must come. And finally, if the temperature is same, then they come together and take it up, and it can also form some uh, structure on the top of the atmosphere. But if it is the two different temperature, for example, they prevail in a situation which is warm, but these and these are very cold, then that time they are looking like lifting along weather fronts. So it is not always necessary for mountain to form the clouds. Yes, mountain can be a good barrier, but without barrier also cloud can be formed due to different other type of temperature, different other type of convection. So convection is the main important thing. That means the heated up surface. So heated up surface give you the cloud development anyway. Is it clear for you, Shubro?
Yes, sir, clear.
So we are in dew formation. So dew formation can take place with two conditions. One is the weather should be very calm and quiet. That means there is no barrier to release the heat from the ground. One condition. Second condition is the ground object. That means the twigs, or branches of the leaves or branches of the trees or maybe the grass, their temperature should have little bit lower than the air temperature. These two conditions give you the dew on the surface of these objects. And now if it prevails for a long time and if the temperature goes to freezing condition, that means below 0 degree, then these droplets of water, they turn to ice, and that we call frozen dew. We don't say that is frost, we don't say, we say this is frozen dew. And you can understand it as it is very spherical or round in shape, so your frozen dew also in this same shape, you can see that. But on the other hand, frost also form, visible frost can be formed in the same directions, but their temperature, the temperature is so low, they can directly form to the, from the atmospheric water vapor to the directly solid form. So there is no intermediate state like dew. So they can form directly from the condensation from the water vapor to the ice formation. And these ice crystals, as formed directly to the water vapor to solid form, their structure is also different. They are looking like branches of trees and delicate ice crystals, which can be seen like this. So their formation and this formation is different, and process is also different, design is also different. So two difference, one is you need freezing condition at the very first in case of frost, but you don't need for dew at the very first, you don't need the freezing condition, you need lower temperature to form dew. And how can you differentiate between them? One is round shape, another is tree-like branching structure. And another difference is, main difference is that the frozen dew is coming from the dew, that means from liquid to crystal. But in case of frost, they come from water vapor to the solid form. So can you now differentiate between frozen dew and the frost? Can you differentiate it? Is it okay for you? Can you differentiate it? Can anybody explain to me what is the difference between frozen dew and frost? Anyone? Can you just explain? Or I can ask also. Maybe Nazmul Shaharin. Nazmul Shaharin. Can you hear me? Hello? Nazmul Shaharin. Can you hear me? Shahjahan Akhtar. Shahnaz Akhtar. Moni. Shahnaz Akhtar. Can you hear me? Hello? Shahnaz Akhtar Moni. Can you hear me?